Gelashashviloi, Kalos Irtahe Sto .NET API Review. And for any of you who can speak Greek, tell me how bad I did. All right. Today's another ARM Intrinsics Day. We won't finish, apparently, even though I feel like I heard, oh, one more should knock this out, but no.
It was one more for the SVE ones, and then we've got SVE2 separately.
Oh. Oh, my poor hopeful naivete. Cool. So first up, loads part 2.
So
Vector X, which we may not have enough people to actually talk about.
yeah, so for the last 4 in that list, the prefetch ones, we should basically already have covered. They're just matching the same names as the vector prefetch that we approved last week. And so they're just prefetch number of bits and so those ones should be non-controversial. Then for the load vector x ones, the contentious point there was just the names, where we've already used a convention here for the other types, such as in Advanced MD and even in Xarc for where they have an equivalent feature. And so in that case, we have what's basically load vector 128, and then we have X number, which specifies the number of vectors that we're loading. So you'd have load vector X2, load vector 128 X2 or X3 or X4. Then you'd have load vector 64 X2, X3, X4. The interesting thing of following that pattern is that here we're loading a variable width vector. And so there is no number to separate the name vector and the X. So unlike other cases, like even matrix 4x4, where we also use a lowercase x to indicate the multiplier that indicates the number of elements, we can't do that here. And so there was some question on, should we keep the lowercase x naming? Should we make it a capital X instead, or should we have some different name? Different name to disambiguate. And that was the point that we wanted more input from API review members on.
Yeah, I think, Emo, you were gone and I was driving your computer when that came up last time. So your input is especially valuable. And Steve, I don't remember you chiming in previously, so.
I did.
If you refresh the page, Jeremy, the names will be fixed for base to address as well.
Fair enough. I'll take it out of the notes of corrections I made then.
So the question was about the X3, X4. Is that what you're saying, Jeremy?
Yeah, because it's... If you read this name, does it occur to you, like, how quickly do you come to the realization of what it's doing is loading 2 vectors instead of loading a Victorx?
Yeah, it does look like it's a vector X. Yeah, we have vector 128, vector 2d6. Apparently we now have vector 2, X2, vector X3. I mean, I'm not recommending this, but the thing that naturally rolls off the tongue would be load 2 vectors, load 3 vectors, load 4 vectors.
I think that was suggested
so the X
last
is basically
week.
times 2 times 3. Is that basically what it is?
Yep. Because
I
the
see.
x2
The
returns 2, the x3 returns 3, and the x4 returns 4.
Oh, yeah.
The other concern with
the
the X would be
load.
someone think. Oh, I was just the other concern with the X would be someone thinking it might mean some kind of multiplication or something. But
Yeah.
what were you gonna say, Tanner?
Well, I was going to say so. The load 2 vector, load 3 vector, and load 4 vector was suggested last time, and I think that's a better option than capitalizing the X. The
Yeah.
only downside there is it's then inconsistent with the load APIs that return load vector 128x2, for example. So we've got two APIs that do basically the same thing.
We have
The only
existing.
difference being the type that they load because of return type, because we can't overload by return type.
We haven't
And now
shipped
with
any.
different names.
We haven't shipped any APIs yet that end with the x2, x3, x4 suffix, right?
Yeah, we have.
Did?
But with a number
Yeah,
to break them up.
we've. Yeah, it's because you've got the 128x2, and for example, matrix 4x4, 4x4 shipped, back in 2014,
that's
10
true.
years ago. The number X number
But
is a pre-existing convention, but here there's no number X number, and so that's where it gets like
But the
confusing.
4x4 one is about the shape, not about how many things are being returned.
Right, but this is also about the shape. Like load vector by 4 is effectively used as saying I am loading 4 rows of vector t columns of vector t dot count columns.
Yeah, I
It's
think
basically doing a matrix load here.
I think it's a little different
That's
because the
its
other case,
intent
it's
even.
the name of the type is matrix 4x4, and you're loading one of those, and it's sort of necessarily part of the type to describe its shape. Whereas here, it's not describing the shape of the type; it's describing how many of the things are being returned. And I realize there's a subtle distinction between how many are being returned and describing the shape of the tuple, but in my mind, there's a distinction.
So what is the need for the X? Why don't we just say vector 2, vector 3?
Because we have types called vector 2 and 3.
Yeah.
Oh, I see.
So I think if we really don't like load vector x2, then I think the best option is load 2 vectors, load 3 vectors, load 4 vectors.
But if
It's
you're
just
saying
then inconsistent.
Yeah, I was gonna say if you're saying we already shipped load vector 128 x2 and that returns a tuple of vector 128t and vector 128 of t, and we shipped a load vector 128 x3 that shipped a tuple of 3 vector 128s. That's what we already did that, right?
Right, and that one we were fine with because it was explicitly, there was the number separating it, so it was visually distinct, and users weren't going to be to disambiguate.
Did we discuss at the time the fact that it would cause a pattern that would lead us to do the same for vector?
No.
Where do you see the load vector 128 times 3? Because APIs of .NET doesn't have one.
They're in the source. They're checked in.
Well, I'm just saying that may mean it hasn't
I
shipped.
think they might have been I'm pretty sure they shipped. And we also had a similar scenario with like transpose and what was it? We've had a few APIs where we've had to do this consideration.
So it is possible that
I
APIs
sent
of
the link
.NET
to
is
it.
outdated because we recently transferred the assets to Azure, but I still don't have the connection strings to update any of the stuff yet. So that's something
GitHub search isn't returning anything in managed code
Yeah,
either.
we have.
I sent a link to it.
I was gonna say we have the intrinsic, but we don't have the method wrapper.
I don't know
It
if
looks like they're commented out for Mono today because Mono doesn't have the support.
I mean, ignoring for a moment what we shipped, I generally dislike using written out numbers if what we describe is fundamentally a variadic set of arguments. I think we should use numbers for that. If we just don't like the x, I'd rather have something like load vector tuples 2, 3, 4, 5, whatever, right?
I
But I
just
think
want to point out that the PR that was linked wasn't in .NET 8. That's .NET 9. So we have not shipped that.
all right, so then we have still ability to fix that.
Yeah, and again, it's not showing up in.
We've also so another example, AVX 512 shipped as shuffle 2 by 128.
Also, real quickly, I know we're punting it, but SME will add these kinds of instructions. So you might want to pick a scheme that would
Yeah.
fit in the future as well.
But this is, I think, to a point Steve was saying earlier, it's kind of describing more the data inside the thing, because this is not returning a 2 tuple, or rather a 128 tuple.
Right, but
I'm just saying
it's
that's a different pattern
convention.
now.
I think the argument is more like if you use an X to describe a rectangular or basically a multi-dimensional layout, then we have precedence for that. If it's just a singular stream, we don't have that. But I mean, that's largely up to us. I mean, we could just say you still use the same naming convention. We call it just 1 times 2, 1 times 3, 1 times 4, right? Or we just omit the 1 and just have this, or we just say tuple, right?
Yeah. Well,
But
we could say it as load 2x vector. And
Yeah,
put
that
the
would
number
probably work.
instead of the spelling it out.
Yeah, I think that would work too. I mean, I would just generally say, I think to me it would be weird to write out the number because now sorting is all fucked up, right? You kind of want them to be in the order of 1, 2, 3, right? So I would, and I think if you describe something that has a shape, I just think it's weird to write it out. I mean, there's a reason why we call it matrix 4 by 4, with 4 being numbers and not written out, right? Same with tuples, right? We didn't name them, we just put numbers in there.
Just for my edification, because it shed some light on it, for those shuffle 2 by 128 APIs, where does the 128 come into it? Because they were everything being passed and returned is vector 256.
It's because so 128 is kind of a fundamental size that all platforms support. Once you get to higher sizes, you start having to consider whether an instruction does it as two 128-bit operations, so the two 128-bit lanes don't cross into each other. And so it's basically as if you had just manually unrolled your loop, or if it treats it as a single contiguous unit, allows the upper and lower indices to cross-contaminate each other. And so the 2 by 128 is basically indicating this does a shuffle, but treating it as if it were two 128-bit lanes rather than one 256-bit lane vector.
Basically, you're doing two different operations that are isolated from each other, but you're doing them at the same time.
Right. And we have different permutes and different shuffles that will do the full 256-bit operation. And so we have to disambiguate between those two concepts.
It makes sense. So it's
it's functionally describing the shape of the data.
Again, yes and no. Yes, in that it's saying that we're splitting this into two things that are 128 pieces and operating on them independently, but the API shows the data types involved don't match that. And again, I guess I realize I'm making a very fine distinction here, but I don't know, I feel like we're overloading the X.
I agree.
Maybe this is one of those cases where like we don't want to return to define a special type because it complicates the JIT and it hinders the standard usage of it in regular code, and so the tuple is the pattern we settled on.
And I assume doing it as outs would also be complicated for the JIT.
Yeah, that's basically a worst case scenario for the JIT because now every single address taken
is address exposed. Yeah.
Yeah. Notably in C, the actual types that these APIs, like the load vector API, load vector x2 APIs and stuff return, they actually have their own types called, for example, when you're talking about advanced SIMD, you have a float 32 by 4 by 2. So float 32 by 4 is describing a vector 128 of float because you've got 4 32-bit floats, and then you've got the by 2 indicating that it's 2 of those being returned in a single structure. And so this is logically the same concept of I'm returning vector type by 2. I don't remember the exact SVE type alias that they use in C.
Well, the ones Jeremy currently has on the screen, I prefer the second one, the 2x vector. But I'd want us to be consistent with the previous APIs we checked in if they're there. And so we'd want to go back and revisit those too.
Yeah, so based on the shuffle APIs, we're doing for x86, we're doing shuffle 2 by 128. And similar things. I don't see ones where we're doing 128 by 2 instead. And then if we've not actually shipped the other load APIs yet, they were checked in for 9 and didn't make 8, then we could say it's consistent to say that these ones are load 2 by vector and the other ones are load 2 by vector 128. And then that follows the same general flow as the shuffle APIs that we shipped years ago for x86, where they are also 2 by and then the bit count.
Yeah, I like that better.
And so, Steve, you basically like the verb here being load 2x to mean I'm doing a load, basically 2 sequential loads and giving them to you?
Well, the verb is load, and the thing that I'm loading is 2 vectors.
That works too.
Yeah, and I think we don't want the S because we wouldn't do vector 128 S's.
Yeah, I mean, this solves the problem that I had of immediately looking at it and being like, what's a vectorx? And it's not great, but I think it's good enough. Was denkst du, Herr Lambert? Are you okay with the load 2x vector?
I think that would, I mean, I think
You're
in
muted,
general, I
Emma.
would say X as an infix makes most sense, right? So if you have something before and after, I think that makes sense. And you kind of want it to be an uppercase letter or a number. So doing 2x vector is better than vector 2x. Oh, vector x2, sorry.
All right, now that the bigger numbers are there, does everybody still feel content with that? Just in case 2 held a special place in your brain.
I mean, 2 is a special
I
number.
think I can live with it. And then I guess we'll leave a note that we want to retroactively fix the load vector 128 by 2 APIs to follow the same convention, and then I'll make sure an issue gets logged for it. And I imagine Kunal or I will get the actual change implemented.
Okay. Yank that back over. Yeah, is op really the right? If nothing else, feels like op should be prefix type or prefetch type, and probably
We
constant
had
expected.
chosen a name. We had chosen a name for the other APIs we looked at, and let me go find it. I think I just forgot to update that one. API or ARM64 gather load. We had done. Looks like we never fixed it from op there either. It's the prefetch type, so maybe just prefetch type would be fine. Or type or whatever.
And I assume it's constant expected.
Yeah.
Because it's an encoding thing.
Yep. Okay, and I fixed it up on the gather loads 1-2 from op to prefetch type.
Alright, then I'll leave out the note. Oh, and yeah, the prefetches. You said we've already used these names?
Yeah, we used that exact name on the gather ones.
Okay.
But prefixed with gather in that case, it was gather prefetch 8-bit.
Alright. Scatter stores.
Yeah, so this is the inverse operation to the gather loads. And I should have fixed all of these up already, so hopefully I didn't miss any. But basically we've got 2 sets of APIs here. We've got scatter, which follows the same pattern as gather, but instead of returning, it takes the data as the last parameter.
Is data destination?
Version that takes. No.
No, address is the
address
destination.
is the place you're storing to, and
Okay.
data is the data you are scattering.
Yep.
And then we've got the version that takes the indices and the version that takes the with byte offsets. So following the same thing we reviewed last week. And then we have the narrowing APIs. So when they were
hold on, Tanner. Do we have saves like this elsewhere with the data being last? Because like just thinking of our span conventions, we're source comma destination, and I can buy that the mask address indices is a destination tuple, but it still feels like to me like what you want to save should be first. But if in intrinsics we already have an encoding of doing it last, then sure.
Yeah, with the platforms. So with the cross-platform intrinsics, we do exactly what you're saying. We put data first, like the rest of the managed APIs. For the platform-specific intrinsics, we follow what C did with its APIs and or what the underlying instruction actually takes its operand ordering as, which is typically how C does their ordering. And we don't want to deviate from that because it makes it harder for users to port their code to C#, and it makes them harder to follow what instructions go where and how register allocation will actually flow for the parameters. So we want to try and exactly match what the underlying instruction is for most of these cases.
Okay, because to me the with byte offsets being a parameter insertion just is mind-boggling. So the destination going from I guess it goes from one kind of 3 tuple to another. But so I guess this overload change here of like that feels really weird, especially when T1 and T2 are the same.
Yeah, it's notably how the things work. We could, of course, go change all of the load APIs we already approved to something like scatter with index offsets or something. But
right, well, because with the gathers it was adding a new final parameter, which is consistent with overload guidelines, and this is inserting a thing where sometimes the type is ambiguous, which violates overload guidelines. So that's really, have we already violated it for intrinsics? And I should put on intrinsics goggles instead of good API goggles. Okay.
We still want good APIs, but this is one of those cases where we explicitly differ because it's what the hardware needs. Domain-specific difference.
Okay. You can return to narrowing now.
Yeah. It looks like I did forget to update some of the narrowing ones to have with byte offsets, which is my mistake. But basically, we have a bunch of APIs here which do they do a store via scatter, and after narrowing the data, and so sorry, trying to think of my wording here. The for store, we don't typically postfix with the type information because overload resolution is enough to do it all. This one in particular might be one where we actually do need to insert the type name because you can narrow from int to byte or short. And it looks like it doesn't differentiate via the mask. Is that right, Tamar, Alan?
Yeah, it's just the instruction that determines what it matters to.
Yeah.
Although, yeah, the mask is still the input vector. Yeah. So it won't distinguish it.
So we do actually need to insert scatter narrowing 8-bit for so the issue so in particular the issue here is that for scatter narrowing that takes a individual address, so the second version there, that one's fine because it actually has the target type in the overload parameter list. So you know it's going from int to short. But for the top one there, because it's taking a list of vector addresses, you don't know what the target type is, and we need to specify that that one is 8-bit versus 16-bit. The first one's 16-bit, and the one a little bit further down is 8-bit instead, the ST1B.
Okay. So first, where does the with byte offsets go? Is that between scatter and narrowing, or after narrowing?
I think we did scatter with byte offsets narrowing is what we had done the ordering for with one of the other ones.
Okay.
Because we had done we had done gather vector with byte offsets 0 extend, for example. So we put it after the operation where the address is relevant.
Okay. So for fixing the places where we have duplicate signatures, do we want to name the types of every scatter, or the sizes of every scatter, so you get the overloads of the 3 different ways you could specify the same input type to something, output size, as proper overloads, or do you want the pointer ones to use simple names and the triple vectors to be weird names?
I don't have a strong preference. Do you, Tamar or Alan?
To me, it makes sense to keep them the same names, but I'm not too strong.
So it's going to be like scatter 16-bit narrowing?
16-bit. Yeah. I am working on fixing them to follow that right now.
Meaning I should just wait and hit refresh and update my whole buffer?
Yeah, I'm just taking a second to... Did we do capital B or lowercase b?
I think capital was on the
Yeah, we did capital.
prefetch that we just did.
Which I was following until the last couple that I pasted. So there's that, and then we just need width, byte, offset. Inserted in a few of them. Sorry, I thought I had gotten all of this last night, but I apparently missed the nuance of the pointers are untyped and therefore overload resolution does not work for them. Okay, if you refresh, it should be updated with correctness now. Oh, it refreshed itself.
Only slightly creepy. Okay. And weird bit trip. Okay. And then these top two you want to leave as simple names.
Yeah, I think so. And unless we have a very strong preference for breaking it apart, and calling it like scatter with index
Well,
offsets
really,
or something.
it's. Do you think that this is a simplified form of? If this is scatter 16-bit narrowing without the narrowing, and you want somebody to see it as scatter 16-bit or scatter 16-bit narrowing, then that would be the reason to
Yeah,
size break these names.
I think
I guess these are only 32s.
I think that one's fine because you're just scattering input type to same output type.
Okay. And then okay, so then we're just pattern the whole way through. I thought that masks were never type variant. Am I, or were never signedness variant? Am I wrong on that?
Yeah, that's wrong. We typically it's T in, T out. So if you do a compare of if you do compare equal on ints, it returns an int back. That way you can flow it through for additional arithmetic or bitwise operations, etc.
Okay.
Because otherwise you end up having to be like, well, you can AND an int with a uint so that you can emulate asking yourself. And that just gets weird.
Fair enough. This one required expanding out more than some of the generic collapses have been, and I was just in my head picturing that the generic collapses were always like vector event because it was only reading some amount of data, but whatever. It's not like it would be the first time I'd misremembered something. Alright, no comments from chat. So we just had all these scatter narrowings gain size modifiers. While scrolling, I saw the word truncate. Is truncate and narrow the same thing?
Yeah,
Okay.
in this context, the original proposal that was generated by the tool had picked the term truncate, but we used store narrowing
Okay.
for advanced SIMD for the same concept, so we're being consistent here.
Yep, that's cool. I was just curious if it meant this was split into a different set or if it was this was the consistent term for the same thing. So
Yeah, it's just changing it from the generated term to the consistent term.
fair enough. All right. I don't hear other feedback. SVE stores.
Yeah, so for this one, we've got store, which follows the pattern. We've got store narrowing, which also follows the pattern. Store non-temporal, which follows the pattern. And then just regular store. Notably, we don't need the x2, x3, x4 on store because the tuple is enough to disambiguate.
Why are they taking a tuple
So
instead
those
of a
can just
flat
be called
call?
store. Because the way we have done it for the APIs that explicitly take a tuple is use a tuple because it requires special register allocation semantics. Basically, they can't be independently allocated. A lot of the times they actually have to be sequential registers, and the way the JIT recognizes that is via the tuple.
And that's worth encoding into the signature rather than encoding into the JIT.
Yeah, because otherwise it gets massively complex and the variables can get split apart in weird ways.
Okay.
From independently promoted, etc.
We have a guideline that says don't put tuples in signatures other than return types.
Yep. This is the special case for that, for intrinsics in particular.
All right. And you're narrowing and non-temporal don't need size modifiers here because they're, or do they? Does your store
because
narrowing?
they're not scattering. Yeah, they're not scattering or anything. They're just going from T to U directly. No special considerations, no special address overloads, and so it matches the existing store narrowing we've got for like vector 128 on advanced SIMD.
Okay. And just being, I don't know. I guess A, there's picky pedantic, and B, there's consistency, or a different consistency. Here it's data, and here it's value. Should these be data 1, data 2? And then as a just legal syntax question, doesn't this tuple itself need to be named?
Yeah, so the syntax, the parameter itself needs to be named data, and then for consistency with how we've done the tuples elsewhere, they need to be value 1, value 2 for the actual items in the tuple.
Okay. All right. I won't write down that we named them because that's just making it compile. Where'd my... Any other feedback? Bloop.
Alright.
Are we off agenda? Yeah, technically we're off agenda here, so is Bitwise what you want to tackle next?
Yeah, this one's fine.
Okay.
So this is the first of the SVE2 APIs. So, much like AVX, then AVX2, this is just the second iteration of SVE. So it gets a separate class. It inherits from SVE. And then most of these APIs are just extensions of what's already on Advanced SIMD, although a couple of them are new concepts. So the first one in particular, Bitwise Clear XOR, is a new concept. It does a ternary operation that is op1 XOR with op2 and the not of op3.
Yeah, those
So,
those need better names.
Yeah, so Bitwise Clear is the terminology that we use in Advanced SIMD. It's the platform-specific terminology that matches what and not is. So that's what the op2 and op3 and not op3 is. That's Bitwise Clear. In some APIs on Advanced SIMD, we do something like operation and add, meaning that it does the operation and then in addition. Given this is a bitwise operation, however, Bitwise Clear and XOR might be confusing.
I mean, that is
So I
the
don't
order
really
it
have
does
a
it.
better
It's Bitwise, because that's what your parentheses say is Bitwise Clear is first.
right. But what I was saying is that calling it Bitwise Clear XOR might be clearer than using the name Bitwise Clear AND XOR.
Oh, because the A and D might be interpreted as being another Bitwise AND.
Yes, even though in other places we do use the term "and" here.
Gotcha.
So that's a little bit of a quirk.
Yeah, and I don't know that we want to start introducing thens.
So I think maybe just Bitwise Clear XOR is the simple and closest to intuitive name there. I didn't have suggestions for op1, op2, op3 because unlike something like multiply add where we can do left right add end, there's not really a name for the operand that's used for the XOR and not really a name for the operands that are used for and or and not. So,
Well, for a Bitwise Clear, they were called value and mask. So, like, taking that and loading it as value and mask here, then I'd call it XOR value and mask.
okay, so
It's not great,
XOR
but
value mask.
but at least it matches. It tells you which one is only being used in the XOR, and then that value and mask are together a Bitwise Clear. See also the Bitwise Clear instruction.
That works for me. Do you have any preference, Tamar or Alan?
That seems reasonable.
Yeah.
Okay, so Zor value, and to be clear, the mask in the ARM Advanced SIMD Bitwise Clear is also that's tilde mask.
Yeah, yeah.
And-
That's the one that's being nodded.
Okay, just making sure it's. My argument of use the same name for the same thing is predicated on that they're the same thing.
Yep. Yep. For bitwise select, this one is simpler. It's existing, and the parameter names exactly match the ones we used for advanced SIMD. So we've got select, left, and then right. Bitwise select left inverted. It does not on the left parameter as part of this. Bitwise select inverted does a not on the select parameter, and bitwise select right inverted does a select on, or does a not on the right parameter. There may be a better name than inverted here.
Okay.
But I didn't
Left
particularly
inverted
like calling it some.
did tilde left. Right inverted did tilde
Yep.
right. And what did the middle one do?
It does tilde select, which effectively inverts whether you're picking left or right. So it inverts the selection.
Okay. The things that algorithms do that you guys think are
I
interesting to encode in hardware astound me.
the things that are necessary for high perf, because having a specialized instruction is better than taking up 8 bytes to encode the same operation, because then you hit memory bottlenecks.
I'm just saying, I don't know when I've ever in my life wanted any of those. So
Ternary logic, for example. So if you want to do condition question mark A colon B, that's what this does. Except it does it across the entire vector. So you can do a conditional select for 16 bytes at the same time, for example. So you can now have branch-free vectorized code.
again, I don't know that I've ever wanted to make 16 conditions or conditional statements at the same time.
I mean, if you're looping with a condition in it,
Fair enough.
now you're just unrolling the loop by a factor of 16, and it gives you perf increase.
Fair enough.
A quick question, Tanner. When we did FMA
Yeah.
versus FMAT, we decided on picking one API and having the JIT figure out which one to use based on how the parameters are used. How come in this case you did split them into left and right inverted instead of just seeing where the not is placed on the input vector?
So for FMA, it's just a question of register selection. Every single one does the same operation. For this one, they are actually doing distinct operations, where the users may not be able to trivially put the not in the right place. They may want to, and they don't want to fight the JIT where it might hoist something as a CSE or similar. And so because these are distinct operations rather than simply register selection, it becomes sensible to expose them.
Okay, cool.
The
Thanks.
inverted is maybe the exception there, because the inverted you could just swap your left and right manually. But left inverted and right inverted are non-trivial to map the Boolean logic in your head around.
Makes sense. Thank you.
Yeah, so that's actually an interesting point, is since in BSL is just BSL, I assume, with the parameters switched, should we cut that one so that we don't have this left inverted, right inverted, and inverted, and they don't all mean the same thing?
Yeah, I think that'd be fine, and because that one's more trivial for the user to understand, whereas if you're trying to think, I'm using a select mask and I'm inverting the bits in left, that's a little bit more confusing to think about than switching which of left and right you're picking.
Okay. cut the middle one. Okay, and then left inverted and right inverted. Now that there's not inverted sitting in the middle, seem fine because it's bitwise select with left inverted. So
yeah.
we can leave out the with.
Then we get to the shift ones. These ones follow the existing names that are used for advanced MD. Some of them get quite verbose, but shift arithmetic rounded, shift logical rounded, shift right arithmetic rounded. So shift arithmetic rounded in particular, it does the count is a vector, and it can be used to shift left or right. When it does a right shift, it does an arithmetic shift rather than a logical one, hence the name. But following the existing convention used for advanced MD on the same API.
And this is
and then
because these are signed, it's negative values shift one way and positive values shift the other.
Right.
Okay.
Yeah.
Yeah, I don't
So if you
care
did,
which way is
if you
which,
did
but
-1, it shifts. Yeah. -1 is right 1 bit.
not the way I would have done it, but okay. Apparently I'm right biased. Because on the number line, negative is on the left. But anyway. Okay, so this intentionally doesn't say right or left because the direction is encoded here, and this is only on signed types.
Yeah, because it's arithmetic, and if you're using an unsigned type, then you typically want the corresponding API just below it, which is shift logical rounded. So you're explicitly opting into I'm doing a logical shift, because otherwise a user might give in a uint, and then because they said arithmetic, they might expect it to shift the sign bit that's actually not there, and you can get in all kinds of weird corner cases. So we explicitly make sure arithmetic is only for signed here, and logical is for both.
Okay, and it takes a signed count because the sign indicates the direction.
Yeah.
And what's rounding in shifting?
I believe, and I'm recalling this off the top of my head. So you know how if you divide by 2, that's equivalent to a right shift by 1. And for division, it always truncates. This one will actually account for the imprecision in that functional division operation, and return allows for returning the rounded result instead of the truncated result. So 5 right shift arithmetic rounded by 1 will give you 3 instead of 2.
Gotcha.
That's a pretty good memory.
Fair enough. That explains the rounding.
Yeah.
Alright, and then now you have shift right with a constant count.
Same API, but taking a constant, and it always does right shift rather than variable shift. So we've got shift right arithmetic, shift right logical, and then we've got shift right arithmetic rounded and add. So it does the shift and then adds at the end, and that's following the same parameter, the same method name, parameter name, and ordering as advanced MD.
If it's the same method name, parameter name, and ordering as advanced SIMD, what's the SVE2 difference?
a vector of t instead of fixed size vector. So instead
Okay.
of vector 128. Yeah. And then we get to the interesting one next. So in advanced SIMD, you have operations that do narrowing or widening. And when you do a narrow or a widen, the way that they work is that they operate on the lower or upper half of the register. So if you're doing, for example, a um, shift shift right logical rounded narrowing on vector 128 of int, you have a shift right logical rounded narrowing lower and low and upper. The lower one operates on the lower vector 64, and the upper one operates on the upper vector 64. For SVE, it does it differently. Instead of operating on the lower and upper half of the vector, it operates on the even and odd indices of the vector. In advanced SIMD, there is a similar concept where we have, for example, transpose odd and transpose even. So by that logic, instead of calling this shift right logical rounded narrowing lower, like in advanced SIMD, we should call it shift right logical rounded narrowing even and shift right logical rounded narrowing odd. And that is the convention I have used for those through the rest of the proposal here. And for almost all of the APIs, this makes sense in the context. There is a proposal coming up, it might even be the next one, for math or floating point, where the convention gets a little bit wonky because we have an API called, in advanced SIMD, where it's called um, convert to single round to odd. And so the name would then be round to odd odd, because it's rounding towards the odd number instead of towards the even number, and operates on the odd indices. So we might have to come up with a different name for that one, but for the rest of them, it follows our existing syntax and doesn't cause conflicts. But I didn't want to get to this without calling out that one, because I don't want to get to the next proposal and us go, well, now we need to go fix all the other names. If you want to see that one, it is
No, I didn't find odd in 94022.
where is it? It's not FP16 that I looked at. It was,
Because, yeah, I assumed
there's
you
the
meant
maths
SVE2
one.
math, which was obviously named by somebody who lives in the Commonwealth.
Yeah. There was another one, which
Here's
there is
here's
even other.
yeah, here's widening odd even. Just apparently odd never appeared.
yes.
Uh.
Yeah, so that one in particular, it's because it's doing a widening and it's taking the odd elements from left and the even elements from right.
So that if it was lower half, upper half, then it
But
would have
that's
been
not
called
the one I
lower
was talking
lower
about.
upper. But they're not doing, because I guess
Yes, and
round
that,
is
yeah.
it would only be something doing rounding. Yeah, I don't see a round to odd in the
Yeah, and
proposal. So
I know I looked at it last night. I'll try and find it, and if I do, I'll bring it back up.
That's one of the ones you've renamed, isn't it?
Yeah,
Yeah. Okay.
it was. Okay, it's 94018. I'm not sure why that's not showing up in the list. Oh, it's because APIReview.net is only showing 44 out of 52 issues. Why is that?
I don't know. Blame Emo.
Yeah, so so for this one in Advanced SIMD, this is called convert to single, round to odd lower and upper, because it's operating on lower and upper. But of course, now we've got that conflict because it becomes odd odd or odd even, which then is weird with everything else. And this is the only API I've seen that ends up making this kind of complex like that. But it's worth calling out because it may influence our decision here, or we may just decide this is one API will break the convention of our past name to make it less confusing or something here. So
Yeah, I mean, I assume we already have an existing pattern of doing suffixes when it's doing this only half of your input is being read thing, but like looking at this one, if it said convert even to single, round to odd, aside from the fact that it uses even and odd, that would clearly state that the convert or the even goes with the convert and the odd goes with the round. And
yeah.
so then you would have convert odd to single, round to odd, which really means the thing we're using as a suffix should have been a verb suffix, not a verb phrase suffix. But I assume that pattern is prevalent.
Yeah, I think so.
Because using
There's a couple
lower and
places
upper, it
where
should
we
have been
do-
like convert lower to single, round to odd. But
Yeah, and there are a couple places where we have put lower or upper or even or odd in the middle of a phrase where it's important for understanding what the API does, particularly when it narrows a particular part of the vector, for example, and then does a saturation on the narrowed result. We might have broken it up in that case. So we do use it as a verb suffix sometimes, but we weren't consistent with that for convert in particular. So
yeah, because here, thinking about that, even though I don't think we're going to use the pattern, it would be, shift even, right, logical rounded narrowing. Because the even is, what are you shifting?
yeah. So for these ones, I've put it in the same position. For all of the ones we're going to go through, I put it in the same position as lower or upper, and just change the lower with even and the upper with odd to correctly indicate that's the elements it's operating on. And then where narrowing odd takes even as the first parameter, the upper version takes lower as the first parameter, so that matches the naming flow as well.
Okay.
It's because the one that operates on the odd elements merges in with the even elements you've already computed. It's the second half of the operation, effectively.
Fair enough. All right, and aside from in a rounding mode, have we used even and odd elsewhere and dealt with the zero indexed versus one indexed languages and thinking problems?
Yeah, for example, that's used in transpose even and transpose odd
Okay.
because that one operates on the even odd elements.
Okay, if we've already used it, then my
Yeah.
defensive carrying is low. But while when writing a program, you think of things in terms of the indices. But well, if you write a thing up on a board and you ask an average person point at the odd items, I think that they're going to point at the first one instead of the second one. But whatever. This is for programmers who know what they're doing, so they should be thinking in terms of the index.
Mm.
Yeah, I mean, definitely the notion of the round to odd for the convert is making me wish we had put the uppers, lowers, evens, and odds after the main verb and before the rest of the phrase. But I don't. I think that means we're gonna take that stance on the convert if that's the stance we take. I don't think it's worth changing the pattern now because now we would just get the worst of all worlds with inconsistencies.
Yeah.
So
Um,
so I think the name as proposed is right. It just took us a long time to get there.
yeah. I just wanted to make sure that this was particularly explained because it's somewhat of a new concept that causes that potential fusion, while also being an existing concept in using the term even and odd in that position, since we do have past APIs that did that. So, sounds like we're good though. So those ones, then we get to shift, arithmetic, rounded, saturate, logical, rounded, saturate. These again follow the convention. Shift right, arithmetic, rounded, narrowing, saturate, even, and odd. And then we've got the unsigned saturate version, also still matching the naming, the word spill order that we did for advanced SIMD.
Like that guy.
Yeah.
Well, that does look like it is the longest name in the proposal. At least it's up my screen.
And then we continue just flowing through the rest of these down to shift left and insert, which is the one that kind of breaks the where the rounded and saturate and unsigned word jargon
I'm amused that
slows down.
calling this function would probably break my normal line wrap rule already. And I'm not even the one who proposed it. Alright, so what's the next thing to think about?
Shift left and insert, few down. That one also follows the parameter names and convention for the advanced SIMD version. But that's the one that kind of breaks the monotony from above. And then we've got the widening operations, which work on even and odd. And then we've got the shift right arithmetic add, shift right logical add, and then shift right and insert to parity the shift left and insert. Then we've got XOR and XOR rotate right. XOR in particular, it does XOR op1. It does op1, XOR op2, XOR op3. So it XORs all of them together.
Right, so have we not had that previously?
No, we've not had one that does all three together previously. And so we don't have necessarily names to use there. Normally we would have just used left and right, but now it's like left, right, and third.
Yeah, value 1, 2, and 3 seems like I think that's what we get in like string concat 4, right? It's just value 1 through 4.
Mhm.
Let me. Oh, amusingly, it calls it arg 0
And
through
then there is
2.
XOR,
But yeah, I think value
and then
1
the
through.
last one is XOR rotate, right? Notably, that should be the M3 should be constant expected byte
Yep.
count. And I'm just double checking which parameter is which, because apparently I missed updating that last one. Okay, so it's XOR of the second parameter. Oh, okay, so it's XOR op1, op2, and rotate by the count. So it's basically left, right count.
And okay, and there's no XOR rotate left.
Doesn't look like it because you can just rotate left by doing the opposite rotation.
What do you mean opposite rotation?
Meaning if you wanted to rotate left by 1, you'd rotate right by bit count -1.
Ah, so it's
So
it's
yeah,
oh, because it's
rotate.
rotate, not shift, right?
Yeah. So rotate left is rotate right by 31. Yeah, 31 for
Right.
int.
Yeah, in my head I was just picturing shifting instead of rotating. So. Okay.
Technically, it's 2 shifts and an OR.
Yep.
What happens here if the immediate doesn't fit in within the encoding?
For ARM64, what we do is, well, and for x86 as well, although it's not necessarily a problem there because they always take any 256-bit immediate. But basically what we do is on import, we say if the constant doesn't fit, we throw a, if it is an actual constant on import and it's out of range, we throw saying this is invalid.
Yep.
And if it's not a constant, we add an arg check. However, we have the flexibility to define a behavior there, especially where it is sensible. So for example, if the user says, I want to rotate by 33 bits, and you only have space to encode, up to 32 because you're only using 4 bits or whatever.
Sure.
We have the ability to say, well, because 33 is the same as rotating by 1, we can mask instead and keep it valid instead of throwing. So we have the flexibility there, and it's really up to the ARM folks on what you want to be the most desirable behavior there, whether throwing is sensible or whether masking is the better option because it becomes the same operation regardless.
Sure. Okay. That makes sense. Yeah. You're not going to do the, like on the Enum way, there's a load of branches.
Where we don't, so where we can emulate it trivially without the branch, we do. So for example, we've got these shift overloads that take the vector instead of requiring the byte. We do import non-constants as that where possible. to avoid the jump table. And so for rotate, we could import it as 2 shifts instead. And the user's still basically warned in managed code, make sure you pass a constant here. So it's really just avoiding pessimizing the non-ideal case. We do have that option though.
Sure. Okay.
All right, so regarding XOR value 1, 2, and 3, for string concat, we called them stir 0 through stir 3. I don't feel like we've been starting with 0 anywhere else. Does anybody remember?
I don't think so either. Even like tuples are value 1, 2, 3.
Okay.
Or item 1, 2, item 2, item 3.
See, also where people are going to get confused between even and odd. But... Okay, good enough. Which one did we just do? Yeah, we just did Bitwise.
Bitwise.
I guess it's just being slower to refresh than in the past. Alright, so you have half an hour. Do you want bit manipulate or math?
I think it sounded like Tamar and Alan wanted us to do the counting one. That one's got a few new concepts. It's not very long though, and so we should be able to get through it.
But that would have been the SV1 version.
Oh yeah, sorry, not that one then. It's the... I think the API review list is missing another entry. Just like with the FP one I found.
I mean, I do have a filter here that only says ARM, so... Like, you may be...
Should... Pretty sure it's all prefixed with ARM64. It will... Yeah, that one.
No, that was the ARM64 one again. Or the...
Well, that one says SVE2 counting.
Yeah, that's the one I opened, and you said not that one.
Or maybe it was was it masks in the name?
Oh yeah, sorry, yes, that was it.
94021.
Which does not say ARM64 in it. Which is why it didn't show up in my filter.
That's weird because it shows up as API proposal ARM64 feet underscore SV2 colon mask.
Yeah.
Imo, your tool doesn't like the name.
And it's SVE2 again, isn't it?
So which name in particular does it not like?
Yeah.
So, issue
API review
94021.
showed it as just mask.
It dropped most of the name.
Oh, if you click on the issue, what's the...
So,
What?
yeah, and it's never been called mask in its history. I looked to see if you had that like you glommed or you missed an
Oh, I
edit.
think I know what's happening. I think I like the tool, I think, trims anything before a semicolon, before a colon.
Because API proposals start that way, and we were tired of seeing all the API proposal colons.
Yeah, and I think there must be maybe there's some bug, or it's a feature that I trim everything before the last.
Maybe you only want to
yeah.
trim off API proposal colon.
So it's
Is that not the one you were wanting either,
Well, 'cause-
Alan?
No,
'Cause
like it's there, right? I don't know why. I'm
'Cause
confused.
They look the same here. I don't know why they got different, but this one just says counting, and this one just says mask, and the rest of these have full titles. Anyway, that's an offline thing. We don't need to burn review time while being surprised at what our tool does.
93964.
That's not showing up because it's not marked ready for review.
Ah,
Okay.
So, is
Yeah,
it?
so it is ready for review. Yeah, it is ready for review. I think it just got missed in the bundle.
Okay.
Yeah, so most of these are fairly straightforward for the first ones. So doing abs so it's doing a greater than comparison of the absolute values. Um, we've typically done compare greater than and then suffixes, so I think this one would be better as compare greater than absolute. Or compare absolute greater than rather than absolute compare greater than. But I don't have a strong preference on that.
Have we had this from any other ISA yet?
No. Uh, we've the closest thing is we have in which we use the naming I'm about to say because it comes from the IEEE 74 spec, but we've got max magnitude and max magnitude number because they do a max operation on the magnitudes of the values being input.
Right, but we don't have
But
a
that
greater than.
specifically
We don't
comes
have
from
like
the IEEE spec.
we don't have like magnitude greater than.
No, we don't today. So far, we've just got compare and then equal, greater than, less than or equal to, etc. And then we've got suffixes like scalar for when it's only doing one. We don't have one that does both a comparison and indicates that it's doing it on the absolute values. But right now, all of the compares are grouped together. So the downside of putting absolute first is it breaks apart the compares.
So the instruction does exist in SIMD, so did we not define it there?
FACGT. Oh, we did. It's just hiding. So we did call it absolute compare greater than there.
All right, well, then we're stuck with it now.
Yep. Apparently I missed it when going through the list.
Because I was going to ask why compare is in the term, because on vector we just call it greater than.
Which actually also,
vector. Go ahead, Tamar.
I was gonna say, since we dropped the mask, isn't the signature here exactly the same as in advanced SIMD? Do they not clash?
No, because it's taking vector of t instead of vector 128
okay, right.
of t.
Yeah, gotcha. Yeah.
To answer your question, Jeremy, we used just the name greater than there because it was matching what vector of t did back in 2014, and that didn't go through API review with the same considerations as most of our APIs. Hence, it's got lots of weird historical quirks like public fields in places. So, not necessarily the best example for propagating to other areas.
Fair enough, but in terms of, yeah, usually it's we've let the intrinsics get the worst name. So if we felt that greater than was the worst name, then it would go here. But in this case, it doesn't matter because the name already exists. Like when you do arm.sve, it's already going to show absolute compare greater than. So we want this to be an overload of that.
Yep. We then have compact. So compact will find the active elements using mask, and it compresses them so that inactive elements are no longer in between the active elements. So it basically finds a new case where there's a match, which is all bits true, or all bits set rather. So if you have all bit set, 0, all bit set, then the returned value will take value 0 and then value 2, skipping value 1. So value 2 gets moved over into value 1's position, filling in the empty slot because it was active.
So this is, you want to remove an element, so you set that mask position to 0, and then it shifts everything with a higher index down 1.
Yep.
Okay.
And then you can use it to remove many elements. So
Sure.
Allows you to very easily merge them together.
And I hope, as with the hope that I have for everything that has a mask, that the things that were masked out have well-defined behavior, like 0 fills the on the right, or
Yep. It still fills.
okay. As long as there's no don't care bits, I'm content.
Yep. If there was, we'd call it unsafe at the end.
Yep.
Yeah. Then we've got the comparison operations covering all the standard comparisons. So equal, greater than equal, less than or equal, not equal, unordered, and notably the reason why not equal exists in part is because something being it's the standard floating point concept of just because something is condition doesn't mean that it is not condition. So because of nan, for example. So nan is both not greater than or equal to and also not less than or equal to. So you have those nots in there to help disambiguate.
Right. So I'm just looking at compare greater than, where T2 not equal T1. And the T2s are always bigger. Which is weird. I think that's actually that feels like the wrong answer.
That one.
Because if left was the bigger
sure.
types, then you could say I have 4 longs in this vector, and I'm going to compare it to 32 bytes, and I'll just say that 0 compares to 0, 1 compares to 1, etc., and the 28 of the bytes don't matter. But I don't know how you compare 32 bytes to 4 longs. Also, note that those numbers are wrong because I can't do math while talking.
Tamar or Alan, do you know what the size difference there is from?
No, I was wondering that myself. From the instructions, I think they're all supposed to be the same. Unless I'm missing something.
Because that's this one.
So
this is suggesting that CMPGT has an encoding that says that the 2 operands are not of the same bit width, or the same scalar width. And while I can believe that, I feel like it needs to be that the return scalar width is the bigger sized item. Just my instinct.
So I think that's supposed to be the.
So I wonder if just your T1 and T2 are backwards.
CMP-CC wide.
Exactly.
I think this is the CMP-CC wide elements one.
Yeah. I was going to add that
which is compare.
Yeah. No, go ahead.
Yeah. So they are in the right order. It's the wide elements version compares active integer elements in the first source vector with overlapping 64-bit double word elements in the second source vector, and place the Boolean results of the specified comparison in the corresponding elements of the destination predicate.
Overlapping 64. Okay, I guess that's true. The second is always a 64-bit type. And it does something. Okay. I don't care what it does.
Yeah, so this is, I think, kind of a new concept because it's basically doing a implicit widening compare, and it sounds like based on the overlapping, it means that so for int too long here, it's going to say that both element 0 and element 1 of left are compared with element 0 of right because they both overlap with right 0. And then elements 2 and 3 would each individually be compared with element 1 of the second, if that makes sense.
All right, so 0 and 1 would compare to 0, but then, and that goes in the 0 position in the output. But then, do 1 and 2 of left 1 and 2 of left can't be compared to anything? I mean, they could, but you're probably not going to do a misaligned comparison.
They would get 1 and 2 of left get compared to 1 of right, and then get put into 1 and 2 of the output.
So 1 and 2 of left and 2 and 3 of left both compare to 1 of right?
So it's 0 and 1 to 0,
Yep.
1 and 2 to 1. So
Okay.
you're basically iterating for every 2 on the left, you iterate 1 on the right. So you reuse the right parameter twice before moving to the next one.
Okay, as long as, again, really the question is, should this say T2? And if the answer is no, then
Yeah, no, it's yeah.
Okay.
It's basically an optimization to reuse right and have smaller indices. So for example, you can use this to do a if values, you can use it to detect overflow as an example.
Okay. Alright, and then I presume that's true of all of these T1 and T2 variants.
Yep.
Conditional extract after last active
then-
element. No, I guess compare unordered
Yeah, so it's
is. I don't remember seeing
compare
unordered
unordered is unordered as it's unordered and ordered are IEEE 754 terminology. Unordered basically means there's an and present.
Okay. Have
So
we
it's
used the term
basically
elsewhere?
saying is one of the compares. Yeah.
All right. This is really just anywhere that we're hitting, things that are still named op or im, and any words we haven't used before. So, is conditional extract after last active element new or existing?
That's a new one.
Okay.
Yeah, that one's new. Tamar or Alan, do you want to explain exactly what this one does?
So basically, it finds the last active element and selects the element after that. So if you, for instance, you've just done an operation and you want to know what the value after the, so say you said find all elements smaller than 0. It finds the last element in your factor that's smaller than 0, and it returns the one after that. It's typically used for instance, reductions when exiting a loop and you're trying to find the element to return.
But your description makes it sound like it's emitting a scalar, but it says it's emitting a vector.
So that's what my next question is going to be. There's a vector and a scalar version, and I only see one here.
Yeah, so the reason most scalar APIs return a vector is because they typically return the value in a vector. And so we want to say vector because then the user understands, hey, this is in a SIMD register. There's some exceptions where they do actually return something in a general purpose register instead.
And
And
Yeah,
in
so-
those scenarios, we typically want
So CLAS is one of those exceptions where it can return it in an actual vector, a SIMD scalar, or a generic scalar. So it has all three variants.
so in this case, the
so
value goes into a vector of 0, and the rest are 0.
yeah,
So
for the vector version. Then there's the version that does it to a general purpose register. And we have two options for that, and we have done a little bit of this and a little bit of that, depending on what's more common and what's more beneficial for the case. So in some cases, we have exposed explicit overloads that would be called something like conditional extract scalar after last active element to indicate it's explicitly extracting a scalar to a general purpose register. And the alternative is we don't expose that, and we tell users just call .toScalar, and the JIT will do the appropriate containment in lowering to make it do the right thing and directly put it to the general purpose register.
So
and so it's
quick
really a
question.
question of, do we want to, yeah, go ahead.
So to clarify what we're looking here at, so the conditional select after is the vector ones. And it's basically exactly the same as a scalar in principle. The difference is that the vector version replicates the value into all lanes, whereas the scalar one just sets the bottom lane. So I'm guessing it's both.
Right. And so yeah, and so we basically have the option to say we have this, and we have another overload that just returns T called conditional extract scalar. Or we can just have this one and tell users do .toScalar on the result, and the JIT can pattern match that trivially. So we have the option of either or for that.
But you don't have the one that writes the value to the 0 lane and zeroes out the other lanes. You get either the scalar or the blast. Because it sounded like there were 3, and I may have used the wrong terms here.
Yeah.
But that there's
No, there are 3.
Yeah. And you've decided that the middle one is irrelevant. Which is fine.
The middle one could also, the middle one could also be pattern masked, or could be pattern matched by doing conditional select with a scalar mask. But that one's a little bit harder to pattern match, and so I guess we have the option of if we were to have all 3, we'd have conditional extract scalar, and we'd have conditional extract
broadcast,
yeah. Or duplicate, or no, it's replicate is the ARM64 terminology. Is that correct?
Yeah.
Is it replicate or duplicate?
In this case, it's replicate.
Okay.
Yeah. So.
Yeah. So it'd be conditional extract and replicate, or conditional extract after last active element and replicate to match the load and replicate APIs we have.
Okay. So. Do you want to make 1, 2, or 3 here?
I think for this one it'd be easiest to do 3s because they are specifically the underlying mask handling APIs. And so since they're specially dealing with masks already, it's better to separate it than require users to basically mask the mask.
to come back to your previous questions on Tanner, as we calls it here replicate, but in the past we've called duplicate. I don't know if you want
And
to call it
we
duplicate.
also used replicate for the load APIs. So
Okay.
I think replicate fits better here. Duplicate comes across. I think we use duplicate specifically for double when it was going from 0 to 2, and therefore it's actually a duplication. There's a lot of different terminology across the platforms and instructions. Like ARM has the actual dupe instruction as well. So, and then of course our x86 has permute and broadcast, and it also has its own duplicate. So we've got lots of terms.
Yep. Okay, so for one, I need what we think the names are going to be for the 3 variants, but then there are 2 other points. One is fallback really before data, and 2 is fallback really a vector?
Yes, and we used default values instead of fallback.
Oh, so the name fallback is wrong. I was going to say you can't use a default value in
the name,
in a non-final.
Yeah. So, yeah, we used the name default values, and the fallback exists for the vector version, and it doesn't look like it can't exist for the scalar version, so that parameter just goes away for the scalar.
Really? What's it do if the last element was active? There's nothing after the last element then, so that would at least my 100% guess on this is fallback is for if the last element was active, or if no elements are active for the next one. So it would need to return something.
Let me try and find the page again. What? Can you scroll to the right just slightly?
Cluster.
See last day. Sounds like IKEA furniture.
So the operation fills in the first
so,
source operand as well.
So they do all have default. So they do all have the default value then. And so it'd be vector of t fallback or default values, and then for the scalar t default value.
Okay, but you want it in this position instead of swapping it with data.
Yeah, because that's the order the registers actually go.
Okay. All right. So right now, all 3 variants have this same name. What do we?
So conditional extract after last active element. Conditional extract scalar after last active element for the one that returns t. And then conditional extract and replicate after last active element for the one that replicates, because we use the term and replicate specifically for the other cases, like a load.
Okay. Well, so is conditional extract scalar? Because if that moves to t default value, then you could leave it as an overload without renaming it. Because then it wouldn't just be return variance, it would be signature variance.
I guess we could.
I'm just asking.
Keep it the same.
If other things would have the same thing.
I think that ends up flowing better. And then we could maybe do and replicate as a suffix. Conditional extract after last active element and replicate. Then they all 3 group nicely together.
Alright, so dump the scalar infix. So you get that.
Yeah, I think that groups nicely.
That's the best alignment you're going to get on that. And then is when a vector is given here and the mask, if the last element was active, does it return this full vector or does it return
If
the
if the
zero
last
lane
element,
or the zero lane replicated or
yeah, so if the last element was from active, it extracts from the zero lane. So it does the same operation but based on lane zero.
right? So if only lane 0 in this is being respected, is default values the right name for it? Because the vector sub 1 is not being respected. Because I feel like I would be confused if I passed in a complicated thing and it got zeroed out when the mask says it shouldn't have done an extract. I appreciate the lack of an immediate yes because it means that my question has merit.
I think it's just we have to double check exactly what the instruction does.
Yeah, so if the last active, so this, if the
If it's
last
easier to talk
element
about
is,
the next one, then that's fine. Or we can talk about the one that's not after, but the one that is select last. But whichever case hits the fallback mode of what happens when it triggers the fallback.
From if the last active element is the final element, extract element 0 and 0 extend that element to destructively place in the destination. If there are no active elements, then destructively 0 extend the least significant element size bits of the destination. So basically it's always going to take the 0th element so it can from the vector input. So it takes a vector because it works on a vector, but it's only going to take element 0 from that ever for the default values.
Okay. But again, like, I can understand it's plural because it's vector, but it feels like calling it default values plural indicates that lane 1 might be
default scalar.
Okay. That's at least a word that makes you think about it. So default scalar, and default value.
It sounds wrong because it's in a vector, but
yeah. So I think that first one is default values, not default scalar. The second one is default scalar because it's replicating. And the last one, it's only it's just the scalar value.
Right. So in this one, it's lane 1 is preserved?
So that one so that one's taking the scalar. No, okay, yeah, I think that's right. I'm sorry, trying to read the docs while mentally grok this is. I believe default scalar is right. Maybe we can just leave a note of confirm the actual behavior, and if it's taking only a scalar, keep it a scalar. If it's taking per element, then default values.
No, it's only taking a scalar.
Okay.
So for the
Well,
For,
no, because there's the
yeah.
C
So
last
for
8 vectors version will leave it unmodified if there is no active elements.
correct. So I was gonna say for the vector version, it takes entire operand. I was also gonna point out that data there is destructive.
Right, but that's not observable to the user. We
No,
hide
correct.
that by using move
Okay, so you're
internally.
copying it. Okay, cool.
Yeah. If it's not last use, we do. One of them is default values instead of default scalar. Which exact one we have to double check.
I mean, I would hope that
But
the
one
and
of them is
replicate
default values.
would be the one that, if one of them treats it as a scalar and the other one leaves it alone, I would hope that and replicate's the one that treats it as a scalar. But
So it's actually the replicate one is the one that takes the that leaves it unmodified if there's no other values.
so and replicate doesn't replicate if it doesn't have a target to extract.
Yes.
I once again am going
Whereas
to
the
lovingly
other
say
one,
I really
zero
don't understand you
extends the
hardware guys.
scalar.
Okay. So default value for the scalar input, default values for and replicate, and
Yeah.
default scalar for the vector return to indicate only lane 0 is preserved. Wow.
That looks correct. And for the one that returns t, the default value should also be t, right?
Okay.
Not the one that
Yeah, this one. Yeah.
that one's fine. Yeah, that one can
No,
be T because it's general purpose register.
Yep. No, I couldn't see the screen, so that's why I was asking.
Yep.
Yeah. And then it's the same split for the next one, the same split of 3.
Yep. Okay. We're 10 minutes over, and the scroll bar.
Yeah, we're not going to finish. So maybe just cut it off there and we can break this into mask part 2.
Okay. So I will delete after conditional extract last active element. Not delete after, delete after non-after, because, yeah.
Yeah, and since I missed this one for SVE, I will work on fixing up I will do the work of making sure the names are adjusted and considered beforehand. I just didn't end up prepping for this one since it wasn't marked ready for review.
Okay. All right. Thank you for being here to explain these things, guys. Clearly, we value your presence in these meetings. And as for the people watching online, if your brain is as melted as I am, or as mine is, then clearly it's time for a break. In my case, West Coast US, it's lunchtime, so I'm breaking for lunch. Everyone else, do something to reset your mind. And we'll see you definitely Tuesday for another general purpose review. There's a whole lot of ARM stuff. I assume we're going to be doing more Thursdays, but we haven't confirmed that yet. And when we do, hopefully it'll show up on the calendar, though today's meeting didn't. But yeah, so we will see you on February 13th, 10 o'clock Redmond time, which is our same .NET time here on our same .NET channel. Auf Wiedersehen.